Hello, you guys. I wanted to go over those two questions that we did in class today. So just the graphs. And so the first one is log base 3 of x plus 1 minus 2. So if we started with log base 3 of x, that would be considered our parent function. So we could graph that first and then do the transformations after. Our transformations over here are 1 to the left because we're, instead of plugging in x, we're plugging in x plus 1. So that's 1 left. And then the minus 2 is 2 down. So if I start by graphing values for log base 3 of x, log base 3 of 1 is 0. Log base 3 of 3 is 1. Log base 3 of 9 is 2. And the last one is log base 3 of 1/3 is -1. So over here we now have 4 points. We're going to graph this. Our vertical asymptote is at y equals 0. Actually, x equals 0. So here's our vertical asymptote. So now we're going to do the transformations. We're going to take each point, take it 1 left and 2 down. So over here, our point 1/3 -1 is going to be -2/3 and then -3. Our point 1,0 is going to be 1 to the left, 2 down. Our point 3,1 is going to go 1 to the left, 2 down, and this last point 9,2 is going to go 1 over and 2 down. So over here is our graph, and in addition, our vertical asymptote moves over to -1 because that's what our left shift is going to do. So over here is our graph, which looks like this. So you can start by graphing log base 3 of x, which is the parent function, and then just move it 1 to the left and 2 down. Or if you wanted to, like what we were doing in class, we were looking for the points that are going to give us whole number solutions. For example, log base 3 of 3 is equal to 1. Log base 3 of 1 is equal to 0. And log base 3 of 9 is equal to 2. Then we're going to plug in and say, okay, in order to make x equal, or this equal to 1, I'm going to have x plus 1 equal to 1, x plus 1 equal to 3, and x plus 1 equal to 9 in order to have those points. So those are going to be my x values. So I want to make x plus 1 equal to 1, which means x is equal to 0. Then I want x plus 1 to be equal to 3. That means I have to make x equal to 2. And the last one, I want x plus 1 to be equal to 9, which means my x is equal to 8. If that's the case, I already calculated log base 3 of x plus 1 down here. So in the first case, when x is equal to 0, I have log base 3 of x plus 1 is 0, and then we're simply going to subtract 2 in order to get the y value for each one of these. So 0 minus 2 is -2, 1 minus 2 is -1, and 2 minus 2 is 0. So over here we have a point 0, -2, we have a point 2, -1, and we have a point 80, just like we graphed it when we moved our values over. All right, now let's look at the transformations and the domain and range in our asymptote. Our transformations was 1 left and 2 down. the domain of the function are all the values we're going to plug in for x. So generally, our requirement for the logarithm is that we can only plug in values greater than 0. Over here, since we had log base 3 of x plus 1, we need the x plus 1 to be greater than 0 over here, which means that x is greater than -1. We can see the same thing on our graph over here. When we're looking at the x values, we have x values that reach from -1 to infinity. So our domain is -1 to infinity. Our range is from -infinity to +infinity. So even though it looks like we're hitting a maximum up here, our logarithmic function keeps on growing. It grows very slowly, but it just keeps on going. So our domain is -1 to infinity, and our range is from -infinity to infinity. Last thing was our asymptote. As we had already mentioned, it's as x equal -1. So one thing you want to keep in mind, that our logarithm always has a vertical asymptote, and it's determined by our shift left or right. We start out with our y-axis, and then we're going to move it left or right depending on what our transformation is.